we have Sahil Bhaiwala, the Director and General Manager of International Public Sector at Scale AI. In his role, he works with governments and state-owned enterprises building practical AI solutions and research institutions, developing national LLMs, and he's here to talk about AI in building permits today. Thank you so much, Sahil.
Thank you. Hi, how's it going? We were originally supposed to show a demo. We were asked not to show that demo for making a much bigger splash later on. So what I'm going to talk about generally, and there's not going to be that many slides, so unfortunately for you guys, you're going to have to look at my high school picture for the entire duration of this talk. But the goal of this is really just to walk through how do you actually build a practical solution enabled by AI to solve hard problems. That's it. My goal is for every single one of you to come away with a much better understanding of how you're actually going to build something in whatever field you're in, whether it's healthcare, whether it's consulting, finance, government services, whatever it is, to be able to come away from this and say, I feel like I have a much better understanding of how I would actually go about building something useful with AI. Because there's a lot of jargon out there, there's a lot of sort of big promises that come, and we want to get a bit more grounded in terms of like what are we talking about when we're saying how AI can help you today. So that's the whole point. All right, I am going to start with just a bit of a specific use case and a specific solution, and I'm going to extrapolate beyond that to make it a bit more generalizable. So bear with me if the particular industry that I pick doesn't sound super sexy or super engaging, all right? But how many of you have lived in a house or apartment before? Just show of hands. I'm amazed if every single person doesn't raise their hand. I sincerely hope you've all lived in an apartment or a house. Okay. When your apartment or home was being built, there had to have been a permit to make sure that that building was allowed, compliant with whatever rules and regulations that that particular municipality or government had. How do you think those permits get reviewed? Anyone? Humans. Humans on the other end of that, just manually looking through a bunch of architectural diagrams, looking at rules and regulations that govern sort of how tall a building can be, how many bathrooms there need to be, where the fire exits need to be, right? And this takes a ton of time, but it's a really repetitive task. This is a really good example of something that AI can help with. But if you just try and throw ChatGPT at the problem, if you pass in all these architectural diagrams and say, is this compliant with the rules and regulations of XYZ municipality, what do you think is going to happen? It's not going to work. It's not going to work even kind of, right? And so if you want to actually make sure that AI can be impactful in a solution, in a problem like this, where it's really complex, right? You're looking at a lot of different things in a architectural diagram that is an image with vector lines, with massive files. One sort of call to ChatGPT is not going to solve your problem. And this type of problem exists in so many different industries, right? Where you have a really complex workflow, you have a lot of things that you're juggling and trying to think about, but it feels like AI should be able to solve it. So how do you actually go about solving it? What we do, and a little bit of background on Scale, just for 10 seconds. We're a company that is founded on the idea of data is the ultimate bottleneck when it comes to building really good AI use cases and models. We started out as the biggest provider of self-driving car data in the world, working with every sort of car company out there that's built self-driving car models. We now are the leading data provider for all the generative AI models in the world outside of China, and work with the likes of OpenAI, Google, Meta, powering their foundation models. And with that understanding of how models work, what they're good at, what they're not good at, we've sort of have this parallel business that focuses on building very specific applications to and really hard problems with AI. So we've seen a little bit of the gambit on where data plays a role, where when you think about a problem, breaking down the workflow plays a big role. And we've now built dozens and dozens of in-production workflows and problems and solved them with AI. So the first step, after you've sort of identified that a problem is worthwhile to solve and hard, is problem decomposition. And this is something that a lot of people sort of brush over when they think about how do I solve a hard problem with AI. If we take that example of reviewing a building permit, there are so many steps involved. Right? So first, I look at a big architectural diagram. It's a really big file. So the first thing I need to do is figure out how can I even pre-process that file in a way that my model can actually ingest it or work with it. When you look at these files, there are several different components of your apartment or of your house. There are floor plans, which give you a layout on sort of an aerial view of where the different rooms are and how they're oriented. There are elevation plans, which is sort of an outside view that talk about how tall is the building in each floor. There are site plans, which give you a whole view of the plot, right? And if you want to understand whether this whole building is compliant, you need to extract certain information from each of these different components of the map. So the first thing you do as a human is what? You try to think about what are the different sections of this architectural diagram that I need to focus on. I'm going to start with a floor plan. The models do the same thing. So you have to break up the problem into every sort of sub-step that you as a human would follow. First, I look at a floor plan. Then I count the number of rooms that are in the floor. Then I try to understand how long or wide each room is. Then I try to count the number of bathrooms that are there, right? All these different steps. Each one of those steps is its own model. And if you're trying to get to the level of quality that you need to ultimately automate some workflows or replace a lot of the human time and labor that goes into it, that is exactly what you want to do. You want to break up whatever problem you have into the workflow that you sort of operate on as a person. What do I do when I'm doing XYZ thing? And how can I break it up as granularly as possible so that I can then create the right kind of models to sort of create that solution, right? So that's piece number one, problem decomposition or workflow decomposition. The second thing you have to do is understand what is your bar for quality and where is the baseline. So in the example of building permits, right? I may be okay if I don't get the exact measurements of every room. If I'm a couple centimeters off, that's probably fine. If I'm a meter off, maybe not, but a couple centimeters is probably fine. But if I get the number of bathrooms wrong, that's unacceptable. I need to make sure I get the number of bathrooms wrong because that is directly tied to certain rules and regulations that impact whether this building is something that could be built or if this floor is compliant. So you really have to think about, in each step of that problem, what do I need to think about as my bar for quality? Is it acceptable to have any kind of error, or is it totally, totally unacceptable? And then you can define, okay, what is my threshold for how good I need to get these models, right? And you can think about it as a map. If I've broken up each problem, or each step of the problem into individual phases, and I now know how good each model needs to be, I have a good starting point. I have a roadmap that I can work from, right? When you have that roadmap, the next thing you have to do is figure out where you are. So how do you think you do that? You take off-the-shelf models, things that are sort of easy to implement and just throw in right into each part of your problem and try to assess how good they are. How do you assess how good they are? Has anyone tried thinking about or would even have an idea of figuring out how do I tell whether a model is at 99% quality the way I need it to be, or if it's at 50% quality? I don't expect you to have, because in almost every scenario that I have heard when people use AI or try to build with AI, they don't really know how you're supposed to go about measuring the performance, okay? And this is critical. If you think about what OpenAI do, what Google does, what Meta does, they all work with essentially test sets or evaluation sets, that they're consistently measuring how good their model is on very specific dimensions or capabilities. So how good is their model at following instructions? How good is their model at providing factual information? How good is their model at summarizing really long context, really big documents? Each of these things is its own capability that they're measuring their models against. So when they release the next version of ChatGPT or they release the next version of Llama, they can publish to you and tell the world, hey, we are really good at these certain capabilities. And they can say that with some measure of confidence. When you're building an AI solution for your complex workflow, you want to do the same thing, right? It feels intuitively very obvious that I should probably test my model and my solution on all the different types of villas or apartments or buildings that it might come across in production. Otherwise, I have no idea if I can trust this thing and if I should actually deploy it. So what you want to do for each of these steps that you've decomposed the problem is create what's called an evaluation set. How do you create an evaluation set? The first thing you do is think about what are the different characteristics or scenarios that each individual model might face. So if we come back to our example of building permits, I might have a house that is 3 stories tall versus 1 story tall. I might have a house that has all square rooms, but some with circular rooms. And I want to make sure all of these different scenarios are represented in my evaluation set, so I can understand where the gaps are. And once I have sort of the specific, call it houses or buildings or apartments that I've aggregated to come into that evaluation set, I want to make sure that I know what the ground truth is. All that means is I actually label all the information to say the correct answer for these villas is 3 bathrooms, 8 meters high, each room is like 6 centimeters wide. I just know what the right information is for each one of them. And the reason that's important is it allows you to test really, really fast, right? So now every time I improve my solution moving forward, when we're talking about the roadmap of getting from our baseline level of quality to our goal, I now can immediately say how good is the model, because whatever the model gave me, I can just immediately compare it to my ground truth. And so now you have the baseline, right? You have your evaluation set that's created, you're going to use as sort of your almost product development roadmap. This is the thing where you're going to anchor on to say, if my model can do really well on this evaluation set, or if my solution can perform really well on this evaluation set, I can trust it, and I can feel good about deploying it into production, right? And you have the ground truth, so you know you can easily sort of immediately test. And this is where a lot of times the fun part comes in. Now you're going to take every single model and try to get it to the bar of quality that you need it to, right? This is where reading papers and experimenting with different solutions and a lot of the ML AI expertise really does come into play. And so if that's something that you as an organization or you as a company don't have, it's something that you're going to want to find how to bring on, whether it's through contractors, whether it's through hiring the right kinds of people, to make sure that you can get a lot of the thinking and research involved in getting these models to sort of higher levels of quality up to the bar that they need to. But I'll brush over that. So now let's say that you've built a solution where all of your models perform really well on your evaluation set, and you feel hunky-dory, you're good to go, let's go put this into production, right? Are you done? Probably the way I'm phrasing the question, you shouldn't do it, no. And that's totally right. Because all you've now done is said, I've made sure that my solution is really good on a particular test set of scenarios. But I have no idea how it's going to perform on things that it's never seen before, right? And I try to make sure that my evaluation set is as comprehensive as possible, but for time constraints, resource constraints, I can't make it so big that it takes so much time to create. So I've created a small sample, right? I've created a subset. And it would be insane to not monitor how important and how good the models are when they're actually deployed. And so it's really important to figure out how do you capture information when your solution has actually been deployed to figure out if it's working the way that you want it to work and if it's actually giving you the level of quality that you want it to have. Any idea of how to do that? I also don't expect you to know the answer to this. But the way we do it is you think about how do you build an application on top of this solution. If you just give an organization, or if you just build in models and you're stringing together APIs, right? There's a huge amount of dependency from each model to each model. So let's say, right, I have 10 steps in my workflow, and every model at 95% quality. What does that mean my holistic output quality actually is? It's 95% to the 10th power, which ends up being, I don't know, like 70, 65, something like that. I can't do that math off the top of my head, but it's much, much, much lower than what you would actually need, right? And so you have to figure out, how do I build in enough redundancy, and how do I build in enough safeguards so that when this model is actually deployed into production, I can make sure it doesn't impact the actual output of my workflow. And so when you think about the steps in your solution where it's really important to keep high quality, and it's really important, like the bathrooms, I can't get that wrong, you may want to create an application where you have a human who's forced to review the actual outputs of that model. So throughout the process, you can make sure that there's enough process supervision so that the models are not as dependent on one another in some big sequence, but you can make sure that ongoing, you're sort of maintaining that level of quality that you need. Now, it still provides a ton of value, because instead of having your one architect on the back end review every single component of this architectural diagram, you're now pointing them to 3 or 4 very specific things that they have to look at. So instead of spending 4 hours, they can now spend 5 minutes, right? This is a huge impact, huge, huge impact. It doesn't need to be automated right away completely, and oftentimes it shouldn't, because you want to make sure that you can monitor ongoing how good these models are. And the value of actually having the human in the loop there at each of these phases is you then capture data on where your models are not performing. If the human says, hey, the model actually got the number of bathrooms wrong here, instead of 2, it's 3, that's data that you've captured that you can use to retrain the model. At the very least, it's information that you have about where your models are struggling. And you can use that to inform how you build and how you improve your data set to train it further, right? So really creating that application layer on top of these models so that there's forced redundancy and forced validation of how good these models are is essential. And it's how you monitor these models in production and your whole solution so that you can make sure over time it gets to where you want it to get to, right? So that's basically the life cycle and approach to how you would build any type of AI use case in production in a way that you can really trust and feel good about. Like I said, we were hoping to be able to demo for you how that actually looks. Fortunately, we can't. So I will end my hopefully not too boring talk here. But if you have any questions about how to build AI in sort of practical ways, would love to hear your thoughts.
Thank you so much. That was incredible, even without a demo. So we have time for one very short question. We have a lady in the front. Thank you.
Hello? Oh, thank you very much for the talk here. So in terms of the building itself, with changes in climate and sustainability regulations, can these models also take into account materials that withstand hurricanes, monsoons, typhoons, drought, but also have a sustainability component like carbon capturing concrete or energy efficient flushing toilets infrastructure when they're creating these models?
Yeah, so basically, how do you think about energy efficiency when you're running so many different models in parallel? And there's, I by no means am a climate expert, and so I don't want to say that, I don't want to say the wrong thing, but I think there's definitely ways when you're building. A lot of what we do is we say, can we use closed source models, or do we have to use sort of open source models? Can we use bigger models, or do we have to use smaller models based on the latency requirement or how fast the solution needs to run? And those are all essentially proxies for how energy consumptive is a particular model. And so if you're thinking about the goal of how do I reduce my carbon footprint, or how do I make sure that this workflow or this solution can run even when there's a huge natural disaster and it's deployed on servers that are in more secure areas, those are all things you can think about as like additional constraints when you're building your solution. So for in a lot of cases, we think about sensitive data, and I'll use this as a proxy. If you break down your workflow, there may be certain places where there's really highly sensitive data, and that data can't be sent outside of the country, or that data can't be sent to GPUs that are off-premise, right? And so in those cases, you may be forced to use a much, much smaller model that you deploy on-premise, which means your path to getting it to where you need to is a little bit harder, but it's just a constraint that you deal with. So I don't know if that exactly answers your question, but it's sort of a proxy for how do you think about like the consumptiveness or the energy capacity of your solution.
Yeah. Perfect. Thank you so much. And
yeah.
that was it for today with Sahil.
Thanks for having me.
Thank you.